Now we're going to go over the medium difficulty recursion questions. I created a new project with a new .c and a new .h file to group all of these questions together. The first question we'll go over is count paths in a grid. This question helps you identify the unique paths you can take in a grid if you are only allowed to move down or right if you start at the top left position. The equation for this question would be paths is equal to paths m minus 1 with n plus paths with m and n minus 1. And we're going to keep running this while m is greater than 1 and while n is greater than 1. So this means we'll have a base case of if our m is 1 or if our n is 1, we'll just return 1 in that recursive call. Here you can see an example of what a 3x3 grid would look like in this example. So let's start with our first path. We will start with 1, 1, 1, 1. Then we'll go to 1, 2, and then 1, 3, and then 2, 3, and then end on 3, 3. So this is one unique path. And as you can see here, we have about 6 total paths for a 3x3 grid. So now let's write the prototype for this function in our .h file. So we'll go here. For this prototype, we'll write int count paths, and we'll take in int m, and we'll take in int n. So let's copy this, and let's write the body inside of our .c file. Now let's write the curly braces. So first, let's write out our recursive call. So what we want to do is we want to return count paths, and we'll write m minus 1, and we'll pass in n, plus count paths, and we'll pass in m with n minus 1. And for our base case, we'll just write if m is equal to 1, or if n is equal to 1, we will return 1. So this should be the correct solution for our recursive function here. Let's go into our main file here, and let's write some test scenarios. So let's write out printf, and let's write paths in a 1x1 grid. This should return 1. Let's call our recursive call now, count paths. Let's pass in a 1x1 grid. Now let's copy this line by pressing Ctrl-C and Ctrl-V. Now let's run this for a 2x2 grid. And for a 2x2 grid, we should have about 2 total unique paths. So 2, and we'll have 2. Now let's test it for a 3x3 grid. 3 and 3. And the result for this should be 6 unique paths. And we'll do one more. We'll do a 2x3 grid. And this should only return 3 unique paths. 2x3. So before we run it, let's just add some new lines here. New line, new line, new line, new line. So now let's run it, and let's see if we get the correct results for this. Control F5. Perfect. For a 1x1, we get 1. 2x2, we get 2. For a 3x3, we get 6. And for a 2x3, we get 3. Perfect. Now we can ensure that this function works correctly.